When you lift a subject out of a background or apply a digital filter, your smartphone reclassifies thousands of pixels in real time. This same processing logic allows an autonomous vehicle to identify an obstacle in a crowded intersection and steer to avoid a collision. As humans, we perform this sorting automatically. Our brains scan a physical scene and instantly partition it into distinct objects: cars, people, and roads. A machine perceives an image as a flat grid of numerical pixel intensities. Without a way to group these values, a machine cannot identify shapes or boundaries. It sees the data, but it lacks the context of the physical space it is recording. To bridge this gap, engineers use a process called image segmentation. This method teaches machines how to partition millions of numerical values into coherent, identifiable regions. Image segmentation determines whether a machine simply logs light values or successfully organizes a physical scene into usable information. The first attempt at solving this involved searching for rapid changes in color or intensity to draw outlines, a technique called edge-based segmentation. Mathematical algorithms called edge operators scan the image grid. When they hit a sharp transition in brightness, the data registers a spike, signaling the computer to draw a boundary. This works efficiently in industrial settings, where robots identify smooth, distinct components moving down a well-lit assembly line. Outside the factory, however, visual noise and complex surface textures often break the algorithm. A computer relying on edge detection often fails to distinguish the physical boundary of an object from a heavy shadow or a textured surface, like brick. The resulting data is too erratic to form a usable outline. Relying on borders alone is insufficient for complex navigation. To accurately interpret a scene, the machine must understand the data within those borders. Instead of searching for borders, engineers began analyzing interiors through a technique called region growing. As seen here, the algorithm starts with a single seed inside an object, evaluating neighbors against criteria like color similarity. Matching neighbors are absorbed, expanding iteratively until the entire region is identified. This approach is vital in medical imaging, where sharp visual edges rarely exist. Region growing allows clinicians to isolate specific structures in an MRI by grouping pixels based on subtle changes in tissue density rather than visible outlines. The method hits a structural limit when separate objects share a color and touch each other, like a dense crowd of people wearing similar clothing. While it successfully identifies the type of object, region growing treats the entire touching cluster as a single entity, leaving the machine without the context to separate individual subjects. Modern deep learning solved the overlapping problem through a leap in capability called instant segmentation. Instead of seeing a generic cluster of a single class, the algorithm assigns a distinct, high-precision mask to every individual object it detects within the frame. This precision is mandatory for navigating dense environments. The vehicle categorizes the bus, road markings, and pedestrians into separate entities, preventing collisions. This breakthrough grants machines the spatial reliability needed to safely interact with humans in a chaotic physical space. Computer vision has evolved from logging raw numerical grids to identifying borders, grouping similar interiors, and finally achieving full environmental awareness. Image segmentation serves as the primary mechanism through which modern artificial intelligence organizes and interprets sensory data. The processing power required for these calculations, once limited to supercomputers, is now active inside consumer smartphones. Beyond editing digital photos, image segmentation translates the physical universe into a data structure machines can navigate, allowing AI to transition from digital screens into our physical environment. You can see this technology in action by using the subject isolation features on your own device. Try it out and subscribe for more deep dives into the systems shaping the future.